In this video, we're going to consider 1,3-butadiene a little bit more. And this applies to the different dienes that we've seen, the different dienes that we'll come across, but we really focus on 1,3-butadiene because it's the simplest one, the simplest version of a diene. And so we typically draw 1,3-butadiene like I have it drawn here. And this we can refer to as the anti or the trans version, where the double bonds are on different sides of that single bond in the center. But we know that single bonds can rotate, so we can rotate around this single bond and get different conformations of 1,3-butadiene. So if we rotate around the single bond, we can get what we call a gauche representation. Now this is kind of difficult to draw, but I have a picture I'll show you in a moment that shows it a little better. But you might imagine the single bond in the same place. Now let's say we have the double bond on the right side in the same place, but we've started rotating the other double bond so that it's kind of coming towards us now. So I'll draw it like on a wedge, for example. So there's that other double bond. So the two double bonds are not directly aligned with each other in the same plane, but they still have a little bit of overlap. This we call the gauche or skew representation. Now we saw with the anti or trans representation that we have perfect p orbital overlap when that 1,3-butadiene is in that conformation. I'm going to scroll up to the Dienes 2 video. We kind of drew that over here. When it's in the anti-conformation, we have perfect p orbital overlap. And so if we're rotating around that single bond, as we move to that gauche or skew conformation, we lose some p orbital overlap, so we have a slightly less stable molecule. Because some of that p orbital overlap is lost. Now we can continue rotating around the single bond and get to another conformation where the double bonds are in the same plane, but they are cis to each other. And this is the least stable conformation of a diene. So here's the image. Let me drag this up here so we can look at it. So in the first image on the left here, we have the trans or anti-conformation where the double bonds are in the same plane. They're all in the plane of the paper. Then and this is the lowest energy. Let me scroll down a little bit. We have lower energy at the bottom here for anti. This whole thing is on an energy scale. Then we have the gauche conformation. This is where we have maybe one of the double bonds in the plane of the paper, and then one is kind of coming towards you in the way that this image is shown here. So that's a little bit higher energy than the anti-conformation. And it requires a lot of energy to rotate, so here's where the rotation occurs, to get to the gauche conformation. And then lastly, we have the cis conformation where the double bonds are both in the plane of the paper, but they're on the same side of the single bond. So we have some repulsions between the hydrogen atoms that are bonded to the carbons, or whatever groups are bonded to the carbons here and here. And so that's the highest energy conformation. And now some molecules are locked or restricted to being in a trans or a cis conformation. For example, this is a common diene that you'll see. Draw it on the side here. 1,3-cyclopentadiene. Because the diene is part of a ring, this is locked into the cis conformation. So that's one example. When that molecule cannot rotate to the anti or gauche conformation, it'll be locked into the cis conformation. Another example of a diene locked into a specific conformation is this molecule here. Again, because we're working in a ring, the single bond cannot rotate. We have a trans conformation here, and so this molecule is locked into the trans diene conformation. So we see on this graph here, the energy scale, that the cis conformation molecule, so really we're looking at energy levels here, here, and down here. So the cis conformation compared to gauche compared to anti is the highest energy conformation. A higher energy conformation is less stable. That also means that it's more reactive. So the next group of reactions that we'll talk about in this class involve dienes that are in the cis conformation.